Welcome to aminacademy.com. Let us go mini tour on engineering. That is, we discuss about various branches. Engineering is a broad discipline that is often broken down into several subdisciplines. Although an engineer will usually be trained in a specific discipline, he or she may become multidisciplinary through experience. Engineering is often characterized as having four main branches: chemical engineering, civil engineering, electrical engineering, and mechanical engineering. Nowadays, various multi-branches are available. Chemical engineering is the application of physics, chemistry, biology, and engineering principles in order to carry out chemical process on a commercial scale, such as the manufacture of commodity chemicals, specialty chemicals, petroleum refining, microfabrication, fermentation, and biomolecule production. Civil engineering is the design and construction of public and private works such as infrastructures, airports, roads, railways, water supply and treatment, etc., bridges, tunnels, dams, and buildings. Civil engineering is traditionally broken into a number of subdisciplines, including structural engineering, environmental engineering, and surveying. It is traditionally considered to be separate from military engineering. Electrical engineering is the design, study, and manufacture of various electrical and electronic systems such as broadcast engineering, electrical circuit, generators, motors, electromagnetic, electrochemical devices, electronic devices, electronic circuit, optical fibers, optoelectric devices, computer science, telecommunications, instrumentations, control systems, and electronics. Mechanical engineering. Mechanical engineering is the design and manufacture of physical or mechanical systems such as power and energy system, aerospace, aircraft products, weapon system, transportation products, engines, compressors, powertrains, kinematic chains, vacuum technology, vibration isolation equipments, manufacturing, robotics and turbines, audio equipments, and mechatronics. Bioengineering. Bioengineering is the engineering of biological system for a useful purpose. Examples of bioengineering research include bacteria engineered to produce chemicals, new medical imaging technology, portable and rapid disease diagnostic devices, prosthetic biopharmaceuticals, and tissue engineered organs. Interdisciplinary engineering. Interdisciplinary engineering draws from more than one of the principal branches of the practice. Historically, naval engineering and mining engineering were major branches. Other engineering fields are manufacturing engineering, acoustical engineering, corrosion engineering, instrumentation and control, aerospace, automotive, computer, electronic information engineering, petroleum, environmental systems, audio, software, architectural, agricultural, biosystem, biomedical, geological, textile, industrial materials, and nuclear engineering. These and other branches of engineering are represented in the 36 licensed member institutions of the UK Engineering Council. New specialities sometimes combined with the traditional fields and from new branches. For example, earth system engineering and management involves a wide range of subject areas including engineering studies, environmental science engineering, ethics, and philosophy of engineering. Aerospace engineering covers the design, development, manufacture, and operational behavior of aircraft, satellite, and rockets. Next we will discuss about marine engineering. Marine engineering covers the design, development, manufacture and operational behavior of watercraft and stationary structures like oil platform and ports. Computer engineering. Computer engineering is a branch of engineering that integrates several fields of computer science and electronic engineering required to develop computer hardware and software. Computer engineers usually have training in electronic engineering or electrical engineering, software design and hardware-software integration instead of only software engineering or electronic engineering. Geological engineering is associated with anything constructed on or within the earth. This discipline applies geological sciences and engineering principles to direct or support the work of other disciplines such as civil engineering, environmental engineering, and mining engineering. Geological engineers are involved with impact studies of facilities and operations that affect surface and subsurface environments such as rock excavations, example tunnels, building foundation consolidation, slope and fill stabilization, landslide risk assessment, groundwater monitoring, groundwater remediation, mining excavation and natural resource exploration. An engineer. One who practices engineering is called an engineer, and those licensed to do so may have more formal designations such as professional engineer, chartered engineer, incorporated engineer, engineer, European engineer, or designated engineering representatives. Design of turbine requires collaboration of engineers from many fields as the system involves mechanical, electromagnetic and chemical processes. The blades, rotor and stator as well as the steam cycles all need to be carefully designed and optimized. In the engineering design process, engineers apply mathematics and science such as physics to find novel solution to problems or to improve existing solutions. Engineers need proficient knowledge of relevant sciences for their design projects. As a result, many engineers continue to learn new material throughout their careers. Engineers should understand what he designed, that for cost, safety and marketability, productivity and serviceability. Problem solving. A drawing for a steam locomotive is given. An engineer is applied to design with emphasis on function and the utilization of mathematics and science. Engineers use their knowledge of science, mathematics, logic, economics and appropriate experience to tacit knowledge to find a suitable solution to a particular problem. Creating an appropriate mathematical model of a problem often allows them to analyze it, sometimes definitively, and to test potential solution. Engineers typically attempt to predict how well their designs will perform to their specifications prior to full-scale production. They use, among other things, prototypes, scale models, simulations, destructive tests, non-destructive tests, and stress tests. Engineers take on the responsibility of producing designs that will perform as well as expected and except those employed in specific areas of arms industry will not harm people. Engineers typically include a factor of safety in their designs to reduce the risk of unexpected failure. The study of failed products is known as forensic engineering. It attempts to identify the cause of failure to allow a redesign of the product and so prevent a reoccurrence. Careful analysis is needed to establish the cause of failure of a product. The consequences of a failure may vary in severity from the minor cost of machine breakdown to large loss of life in the case of accidents involving aircraft and large stationary structures like buildings and dams. Computer uses. A computer simulation of a high velocity airflow around a space shuttle orbiter during the re-entry. Solutions to the flow require modeling of the combined effect of fluid flow and the heat equations to be done. Graphic representation of a minute fraction of the WW demonstrating hyperlinks. What hyperlinks here? This demonstrating this graphic representation of minute fraction. One of the most widely used design tools in the profession is computer aided design, that is CAD software. It enables engineers to create 3D models, 2D drawings and schematic of their designs. CAD together with digital mockup DMU and CAE software such as finite element method analysis or analytic elements method allows engineers to create model to designs that can be analyzed without having to make expensive and time-consuming physical prototypes. The engineering profession engages in a wide range of activities from large collaboration at the societal level and also smaller individual projects. Almost all engineering projects are obligated to some sort of financing agencies, a company, a set of investors, or a government. Engineering is a key driver of innovation and human development. All overseas development and relief NGOs make considerable use of engineers to apply solutions in disaster and development scenarios. A number of charitable organizations aim to use engineering directly for the good of mankind. Code of Ethics. Many engineering societies have established codes of practice and codes of ethics to guide members and inform the public at large. The National Society of Professional Engineers Code of Ethics states that engineering is an important and learned profession. As members of this profession, engineers are expected to exhibit the highest standard of honesty and integrity. In Canada, many engineers wear the iron ring as a symbol and reminder of the obligations and ethics associated with their profession. There exists an overlap between the science and engineering practice. In engineering, on applies science, both areas of endeavor rely on an accurate observation of materials and phenomena. Both use mathematics and classification criteria to analyze and communicate observations. There is a real and important difference between engineering and physics, as similar to any science field has to do with technology. Physics is an exploratory science that seeks knowledge of principles, while engineering uses knowledge for practical application of principles. The former equates an understanding into mathematical principles, while the latter measures variable involved and creates the technology. Engineering is quite different from science. Societies try to understand nature. Engineers try to make things that do not exist in nature. The study of human body, albeit from different directions and for different purposes, is an important common link between medicine and some engineering discipline. Medicine aims to sustain, repair, enhance, and even replace function of the human body if necessary through the use of technology. Conversely, some engineering disciplines view the human body as a biological machine worth studying and are dedicated to emulating many of its functions by replacing biology with technology. This has led to fields such as artificial intelligence, neural network, fuzzy logic, and robotics. There are also substantial interdisciplinary interactions between engineering and medicine. In business engineering deals with a relationship between professional engineering, IT system, business administration, and change management. Engineering management or management engineering is a specialized field of management concerned with engineering practice or the engineering industry sector. In political science, the term engineering has been borrowed for the study of the subject of social engineering and political engineering, which deals with forming political and social structures using engineering methodology coupled with political science principles. Marketing engineering and financial engineering have similarly borrowed the term. We have done. Please subscribe our YouTube channel.